Hello everyone, welcome to Learn Overflow. In this video, we will look into this LeetCode problem, a prefix and suffix search. So again, this is a hard type LeetCode problem. We shouldn't be worried about that. Let's read into this and understand what this question is exactly asking to us. So it says like we need to design a special dictionary, okay, with some words that searches the dictionary in it by a prefix and suffix. So it says that there will be some words in our dictionary, and we should be able to search in our dictionary using some prefix and some suffix. All right, let's understand more into this. So it says that implement the class word filter. So it's as say there is a class word filter being given to us, and we should implement this class word filter. Now, in this class, there is a method like word filter, like the constructor, with a string words being given to it. All right. So it says that this method, like the method on line 3, you see here. So this is like it says it initializes the object with the words in the dictionary. Okay. This is just initializing our object with the words being given to us. Okay. And there is another function that is function f, and it takes two parameters, a prefix and a suffix, two strings, and it should return us the index of the word. Okay. It should return the index. That's the index of the word we should return. And that's why you can see like the return type is an int, okay, over here. Now, it should return as the index of the word in the dictionary, which has a prefix and the suffix, okay. If there are more than one valid word in the dictionary, one valid index, then return the largest of them, okay. If there are no such words in the dictionary, then return -1. That means we should search using this prefix and suffix if and return the index. That's the first thing. If there are multiple words we find with the same prefix and same suffix, we should return the largest of them. I mean, with respect to the length, like the length of each of the word we have. So the largest among them should be returned, and remember return the index of the largest. Okay. So you need to have a note of that. And in case there are no such words like that, then we should return it -1. Okay, so it's a pretty good question. Seems like let's understand the constraint given to us. In the constraint, you can see that the words being this particular string we have. Okay, so it says that words dot length. So this array length is like less than equal to 15,000, and minimum there will be 1 word. Okay, all right. And it says like words of I dot length is 10, like maximum 10, minimum 1. So that means each of the word within this words array. Okay, within this words array, each of the words will be like a minimum 10 digits, or let us say 10 alphabets will be there. All right. And also it mentions that the prefix length and the suffix length will be 10. So, okay, this is something you need to note. Like the prefix length and suffix length can be 10. Why I'm saying so, I'll just explain while I'll explain this example. Okay. And then it says the words I, prefix, suffix consist of lowercase English letters only. So if this is lowercase English letters only, then you are sure that maximum 26 characters are there only. Okay. So that at most 15,000 calls will be made to the function f. So a maximum 15,000 calls will be made to the function. Okay. So if we need to handle 15,000 calls, we should be careful about the time limit. Okay. It may go a time limit out of it, what is it, exit time limit. So we should be careful about this thing. Now, let's understand the example given to us. So in the example, they have given us like a function called, like a word filter is being called, that is like this function is being called. And first word filter is being called with a string. So with a string, you can find that apple is a string given. And here, whenever this f is being called, this a and e is given. So in that case, we can find that a is an prefix is there and e is in suffix is here. And thus it's written as the index 0. That's the apple being the 0th position of this. All right. So let's take some other examples and try to understand more in depth of it. All right. So here I took a same example. That's a function called to the word filter, and there's like this f is being called. You can see that the same prefix and suffix a and e is giving to us. Okay. So in this case, say I just increase the number of words in the string array. So in that case, you can see there's one word apple, there's one word applet, and there was one word a. Okay. So what exactly we're supposed to find? We're supposed to find the index. Okay, so we need to check for the prefix being a. So here we find that there is an a over here, there is an a over here, and there's an a over here. All right, so we find that all that is in our like all the elements in our array words have our prefixes there, and we need to find a suffix as e. So we find a suffix here e, and we find the suffix here e. So no way, this is not our answer. Okay, so we found that there are two things. Now if we look at the indexes, this is at index say 0, right? This one is index 1, right? And this one at index 2, right? So if I just that's what we find, that 0, 1, and 2 being the indexes. Now we need to what we need to check. We first check that the word starting with a and ended with e. So okay, the word starting with a and ending with e. We found all those words. Like there are 2 words. Okay, so find the index of the word filter sequence. Okay, in this word filter sequence, we found the index 0, 1, and 2. The next thing is return the highest index or return -1. Highest index in means that return the largest one of them. Okay, when it says like we should return the largest of them as per the question, that means we should return 2. Okay, and that's the largest one we got over here. Okay, that's the index being the largest. So that's what we should return. In case we couldn't have find any word like that, we should have returned -1 as an answer. So here in this particular example, we will return as 2 as our answer. So that's what the question is. Now, if you just think more deeply, so the question can be a bit more difficult as well. The question can be, without giving A, it can give like AP. It should start with AP and end with E. Okay, so in that case also the answer will be to that A. But so AP and E being given as our say suffix one. Okay, so this is a prefix and this is a suffix. So in that case we have written P. But remember, it's not a single word. It can have a multiple letters in it. So whenever this kind of problem comes into, the best thing we can do is a try. Okay, so what is a try? A try is an advanced data structure and is sometimes also known as a prefix tree. So try is like built to solve this kind of problems actually. So it is like a tree that stores the data in an ordered and efficient way. So thus improves our speed and time complexity also. So generally try is used to store strings, and like each node of the try has as many as 26 reference pointers. Okay, so as an example, if you just look into this try as an example I took here, so you can find that I took like words can have like a cat, a car, a dog, okay, a pig, pickle. So this can be a words array we have. So how try stores them? Try is storing them like C, then CA, and then it stores CAT. Like each, you can find that it's like each character is being stored. And then when it comes for car, we find like CA is common, and then it store like it changes one more branch, like creates one more branch and stores like R to it. Okay. So that's like cat and car. You can see it helps in the prefix that, okay, it starts with cat. So C is already there. Okay. So that kind of prefix and suffix helps over here. When it comes to dogs, it's like DOG is being stored over in this fashion. Okay. And when it comes to the pickle or when it comes to the pick and pickle, so see, it says like PICK, pick is there, and then a pickle is just by adding two more nodes to it. So each of the nodes in a try is like a 26 character array. Okay, so remember like it's more like 26 spaces. Okay. So each of them is being highlighted, and thus in that manner, try actually stores all our elements. Okay, so it's like you see a P being written here. That means like the Pth element, whichever the notation is being highlighted, and others are marked as false. So that in that manner, try stores the whole array and helps us improve this solution. So now we'll move into a working solution way and find out how we can actually implement this in try. So we are back, editor, and let's write some code and complete this program. Okay, so let's go ahead. As we said, we need a try initially to go ahead with this code. Okay, so for that, let's build our try class. Okay, so I will be creating an additional class other than this class. So in that case, we need to create objects and all. So for that, better create an inner class within this, and let's go ahead with that. So here I wrote like two things. That's a try root node. As each of the node we have in our try will be called like this, like a root node. I gave a name to it, and then there's like index list. So index list will store at each node what are the index that are there still in that node. So index list will help us to return a final answer, that the answer we need here, that the index of the word. Okay. So that will be helpful for us. All right. So moving ahead, we have this try. We just have a constructor over here to just initialize our array over here. So 26 character. 26 character being like it only says the consists of lowercase English alphabet. So those are the 26 characters we have, and that's more or less the try data structure we created over here. Just a different class to help us going with this program. Now let's move ahead with this. Like a word filter one, and here the first thing we need is a try node, like the node of the try, right? So we took like two variables over here, which will help us with one will be referring to the class. So each of the object of try will have an particular array with it and a list of indexes on that particular level. Okay, so that's we got, and the words will be the global variable that store our these words over here. Okay, so let's go ahead and just initialize them over here and try to initialize this root for that. So first thing is we would go ahead with initializing the words and then the try. All right. Here you can see like the first we just initialized our variables over here, like the global variables we had, and then we just took another object that you can see the try node, and this object is referring to our root object. That's a basic object we have, so that we keep this in hand, so that we can traverse in this root and like add all our words to this child nodes we have, and then we don't have a problem to just refer to the initial node, like a topmost node for us. So that's why we just kept an additional for us. Okay. Moving ahead, we need to add those words one by one in our like try classes, and then fix them according to them. Like all those should be added in our this arrays. Like, okay, let's go ahead and do that one by one. Let's look in depth to this line. What we are trying to do. So we have like an array going from like a normal loop going through all the words we have. Okay, so one by one, all the words will be taken, and for each of the words, we're taking each of the characters over here. Okay, like each of the characters of the ith question word we have. Now we're checking this root referring to our object array we have over here, and then we're checking to root dot root node. Root node is basically root is the object of this try class. Okay, and this root node you can find this is the array of type try. So we are taking into this root node, and then we are just getting the ch minus a. So ch minus a is what? Ch is the character of the we are currently have over the character of the words array. Okay, and when you minus a character a, that means it gives us an integer value over there. Thus we can have an integer value for this array over there, and we're checking if the particular node, like a particular root node value, the particular index of our root node is null. That means there has been nothing being pointed to there. So that means it's null, like nothing is there. Okay, so if that is so, then what we need to do, we need to add a child to that, right? So just we'll do that. If that is so, then root dot let's do something. Let's change its name to something else so that it becomes helpful to understand at each question. Let's change this to try ARR. So try ARR basically means that the try array we have over here. Okay, so I'm just changing this to try ARR and this also to try ARR, and that's all we had over here. Okay, so we're just doing that in the root in the particular object. We just add the particular value, and then we'll just say it is equal to a new try. Try is in class, so it's just okay, fine. So that's what we do. We did a new stuff being added over here. All right. And in case this is not an particular root, like the if it's not null, that means we have some words in it. Then what we'll do, we'll simply say we'll simply move into its child node. That is the try array. We'll move into that. So root dot try array, and that will be again ch minus a. So this dot index list, then we'll just store the index we have over here. Then dot add, then we'll just have this I being added over here. So index list is basically storing all the indexes, as I said earlier, like all the indexes that are being pointed at this particular try node. Okay, so we got it here, and then we'll simply move into the root of the current node, like the current position being pointed at the ch minus a, like and the try array. Okay, so we'll say root equals root dot try array of ch minus a. Okay, so we just moved into that, and so that we can just build a tree out of there. Okay, so this happens for each of the word. We go for each of the characters, like character by character, and then try to go ahead and do them one by one. Then after that, we'll simply when we're moving to the next word, we need to point the root to the exact initial node of the array, right? So here, after this one by one, like a whole word is completed, then we move to the next word. For that, we'll second point root to our node. Node being, you can see that's why we just took an additional pointer to our initial node. Okay. So thus, we just get building this word filter, like this object getting built. The try is getting built with this particular steps. You can understand how this is going on. Now, the most important part to get our prefix and suffix part. Okay, so doing a prefix and suffix part, we should first need our first thing we need is our access to this try root, like this thing. So we will create an object over here, like pointing to that root, and then so the main idea being, if we just use this root all over there, then we are traversing the original pointer, but it's not a good thing to do. So we'll just go back to the next new point over here. All right. So we'll just first take a pointer through that root, and then we'll traverse through a prefix array. Okay, we'll find a prefix array, like each of the words, not prefix array, rather the string prefix, and we'll traverse to each of its character and try to find out like if that particular node is null or not. Like try to find out that we have a child or not. Like we got the particular prefix is there or not. In case there is no prefix, then we should return -1, right? Like if prefix is also only not there, there's no need to check for suffix. So we'll go with that, and then we'll move ahead with further logic. So first write this part only. So we just traverse through the whole prefix stuff, just finding out that, okay, we got our prefix. And in case anywhere we just find that this is null, that means we don't have a exact prefix in our try, right? So in that case, we'll simply return null. That's the only case we'll return, or else we'll just keep traversing through our prefix and finding out all the elements we need. Okay, that's how we just build our prefix. Now, the next thing we need is our index list over here. Okay, we'll just call our index list. Rather, we just have a local for that. Yeah, we just got a local for that, and then what we'll do in this list, we will go ahead in a reverse order, like with each of the element in the list, and then like from the size -1 till 0, we'll go in a reverse order in this list. And so, what is this index list? We are in a position where, like, what exactly I mean to say here is, like, say like there was a node like this, okay, it got some node over here, and then we're just moving back. So this is the prefix we have. Okay, this is the prefix we have. Okay, so I'm just like pre over here. So this is the prefix we have. And then what I'm trying to do at this particular node, we have an index list, right? A particular index list for us. So with this index list, we have all the indexes being with us, right? Indexes of all the words that start with this, right? That we have with that. So now we can do is like we have this words array, this words array, and we'll get like for each of the index in this word, we'll go reverse order. So if we go for reverse order, that means the highest index will be at that position, and we'll go we'll go in the reverse order in the words, and we'll use a string, a function of string that is ends with something. So the function of string will help us ends with, and then we'll find if it ends with our suffix or not. If it ends with the suffix, we'll immediately return our particular index we have. And else, if after traversing the whole index list, if we do not find anything out there, then it's like we will return like -1 for us. So that's what our main idea over here is. Okay, so let's clear this off and start writing. So that's what we try to do over here. And then I think this is enough for this code, and this should work for us. So let's try to run this once, and then try to find a solution, like whether it works or not. So that's all about this video, guys. I hope you can understand. There can be other implementations as well, which will eventually help us for making this runtime bit lower. But I don't think you can make it lower less than 100 ms or less than that, right? So more or less it will be like that, because we are traversing through string, and traversing through string anyways takes some time. So thank you all for watching this video. I hope you can I can make you understand how this thing is working and all. So hopefully see you soon in my next video. Make sure you just check the description for all the stuff you want over here. All right. Thank you all.